Hello everyone, welcome back. To continue our practice on array data structure problem solving, we will look into the Leetcode medium level problem today and understand the solution by step approach. So let's start. We will look into the Leetcode medium level problem called container with most water. Let's understand the problem statement in detail. So the problem statement says we have given an integer array where each element in an array represents the height of the line. For example, the element at index 0 is 1. It means that it is representing the line of height 1. The element at index 1 is 8, which is representing the line of height 8, so on. So what do we need to check? So we need to, if we see, right, if we check any two lines along with the x-axis, you can see it is forming a container like shape, right? And we can store the water in that container. So we need to check all the containers which are formed by any combination of two lines, right? And among these containers, we need to see the maximum water stored by any of such container, right? How can we calculate the maximum water stored? It is basically based on the container area. So container area is calculated by distance between the two lines, which is the x-axis. For example, here 8 minus 1, which is 7, which is x-axis, which is basically the width of the container, and height of the small line, which is the 7 here. Why small line? Because if we don't consider the small line, the water will spill out of the container, and we need to strictly consider the water which can be stored inside the container. Okay? So in this case, you can see the distance between these two lines. The red mark is 8 minus 1, 7, which is width, into 7. So 49 is the area of the container. And we need to find out all such containers by taking the combination of any two lines, right? And whenever we see that what are the container area is calculated, if it is greater than the maximum till now we have found, then replace it, right? So for this problem, if we see, if we check all the containers, all the combination of two lines which are forming the container, the answer comes 49 for this problem, right? So this is the problem statement where we need to find out the maximum water stored by any of such containers which can be formed by any combination of two lines. How can we solve this, right? If we see, one way is that, as we saw in a problem statement explanation, we can check for each line and check for the second line on the right side, right? So for each element, we'll be again and again checking the all the lines on the right side, compute the area, and then return check the maximum area visited till now, and then replace it if the current area is max, and like that continue till the end and return. So if you see, for each element we are traversing rest of the array. So let's say n lines are there, or n numbers are there, and elements are there. So n into n traversal we are making, which is O of n square. So this is not a optimized solution. So how can we optimize it further? So if we observe the property of this particular array, right? So how the container area is calculated? It's basically width and the height, right? The small height, and that is the area. So what we need to check here is we need to maximize the width and then maximize the height. So fine. Now, how can we maximize the width? If you see, the width is maximum when you take the two lines which are far from each other. For example, let's say if I take this line 8 position line and 0 position line, the width is 8, which is the maximum, right? If we take any two combination, like if we take the line at 1 and line at 6, the width is 6, and here the width is 8, right? So we can use two pointers. One is left, which is blue one, and one is right, the yellow one. So here we already fixed the maximum width which is possible, right? Good. We have fixed our width. Now, how can we maximize our chances of getting the maximum height, right? So if you observe one thing,
the container size is always restricted by the small height, right? So once we find the container area, which pointer we need to move? The blue one, the left one, or the yellow one, the right one? So if we observe this, we are always restricted by the small height. So if we move from the small height, the pointer to next, then we will get more chances of getting the taller line, right? But if we move the pointer which is at high height or tall height compared to the other pointer, then we will lose the capability of finding the maximum area because we will be still restricted by the small height, right? So let's understand here. So we initially put our left at 0 and right at 8. So what is the area here? 8 minus 0, which is 8, that is the width, into 1, small height, right? You can see our height is restricted by the smaller line. So max is 8 now. Now if we move here, then because we don't want to get restricted by the small height, that's why we are moving the pointer which is pointing to the small height compared to the other pointer, right? So we move here. Now what is the width here? Area is 7 into 7. Width is 7. 8 minus 1 is 7, and 7 is the smallest line height, right? 49. So it replaces the max to 49. Now, because this was a high height compared to this, so we moved the right pointer. Then check the area here, which is 7 minus 1 is 6. And the small line is 3, so 18. So it is not more than the current previous max. So continue, move the pointer which was pointing at the small height, right? The area here is 40, and then now the height was same here and there, so it doesn't matter which pointer we move, so we just move the left pointer. Okay, so height here was 8, height here was 8, so we can move any pointer, right? It will not impact our area calculation. So we moved the left pointer. So if you see, area here is 6 minus 2 is a 4, 4 is a width, into 6, which is the height of the small line, which is 24. It is not greater than 49. So continue. Now this line was small, that's why we moved the left pointer. Here again check the area, which is 6. So continue moving our left pointer. Check the area, which is 6 minus 4 is 2, into the small line is of height 5. 2 into 5 is 10, which is less than 49. Continue. Here the area is 6 minus 5, 1 is the width, into 4 is a small line. So 4, which is less than the maximum we have observed till now, which is 49. So now left and right, when they reach, when they face each other, right, when the difference is less than or equal to 1, then break. And then we found the maximum as a 49. So 49 is the answer we got. So we saw how the two-pointer approach helped us by using the property of the width and height of the given problem, right? The way we maximized our width by putting the left pointer at first and right pointer at the right end, it maximized our width. And then to maximize our height, we were moving the pointers, the pointer which was pointing to the small line, so that we will not be restricted by the small line. So hope you understood the explanation. Let's come to the solution. So we took the left pointer, which is pointing at the beginning, and then the right pointer, which is pointing at the end. Max area is 0, and we are traversing till the left is less than right. Then we check which is the minimum height. Then what is the max area? Max area will be max of current max area, and then the current area will be minimum height into, which is the height, and right minus left, which is the width, right? And then if height is if the height of left is less than the height of right, then move left plus plus, otherwise move the right pointer, right? And after we complete the loop, return the max area. So what is the time complexity here? Which is we are traversing only the one time complete array. So n is the number of elements in array. So O of n is a time complexity, which is much more optimized compared to the O(n) square solution, right? So O of n is a time complexity, and so this problem is optimized. We came up with the O(n) square approach first, and then we optimized to come up with the O of n with the two pointer method. So hope you understood the solution and explanation. If you like the video, please share and subscribe. Thank you.
Hope you understood the solution and more importantly, learned about the ways to approach the problem. If you like the video, please share and subscribe. Thank you so much. Keep practicing.